Assalamualaikum and hi, nama Farhan Zuhad bin Razan. Nama cik nama BEJ304-125. Me and my group members, Muhammad Hamzi bin Hamdan, are going to present for our project, which is part of the bandpass filter. So, a little introduction about our project is we are required to design a fourth order bandpass filter using OM with a butterworth filter design, which this butterworth filter will produce a maximally flat response with no ripple. So, for our specification, we have a mid gain is 75, our low cutoff frequency is 1 to 5 kHz, and our high cutoff is 15 kHz. Our calculation, the N is for the number of order, which is 4, and this is the polynomial equation for butterworth filter. And to obtain the gain, we use a 20 log A, which our A is 75, so we can get 37.5 dB. So in a high pass filter, we assume the value of R1, R2, R3, and R4 as 15 kHz to obtain the value of capacitor. And then for low pass filter, we use the same technique by assuming the value of R5, R6, R7, and R8 equal to 10 kHz. Then we can obtain the value of C of is 1.06 nanofarad. We also assuming the value of RA1 and RA3 as 20 kHz to obtain the value of RF1 and RF3. So the total of gain of A is obtained by using the damping factor, so that the value of the total of A or the value of gain can be used to obtain the value of RAF and RA5 for the non-inverting amplifier. Then I will continue with the simulation result. So this is our circuit. We have built our circuit using our Fortis software, which this circuit is consists of second order high pass filter with a second order low pass filter with non-inverting OM. Then this is our waveform. So as we can see here, we have a very clear bandpass with our response, which for our low cut of frequency, we have 32.7 dB for the gate, and for the mid or for our bandpass, we have 36.9 dB, and for high cut-off frequency is 34.3 dB. And lastly, for its low, we obtain 39 dB, 79 dB as in theoretical, it's supposed to get 80 dB for fourth order filter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hamzi bin Hamdan. Nama battery CE200-1A1, and I will present about the result for our hardware. So this is our hardware. I will explain detail about about the connection hardware. So this is our result. As you can see, this is 1.5K low pass, 50K is high pass, and is a mid frequency center. So this is our actual hardware result. As you can see, the source is negative 46, and frequency for frequency loop 1.4. Okay, we got a gain in 6.1 dB, and frequency mid 457, and gain is 6.1 dB, and the frequency high is 50. Gain we got 5.3 dB, and then we compare the result. So you can see the source different is insulation we got 7.9, and to hardware we got a 46. So we get error in 41.72%, and the frequency difference is in dB. Here we can see the simulation we got 32.5, and the dB low cut off, we got 6.1. So we got error in 81.23%, and the high cut off we get installation is 34, and to Huawei we got 5.3, and we got error in 84.51%. So in conclusion, we can conclude that we have achieved the objective of our project, which to design for order bandpass filter. The characteristic of Butterworth filter can be seen where it is ripple in response. Just our hardware, you see this wire rack is the input where we connected from function generator, and then okay, this high pass, low pass, and non-inverting. So okay, you see the or with the red line plus with is connection for plus VCC, and the blue line is negative VCC. As you can see, each IC the positive VCC all connected to pin number 7, and negative VCC connected to the pin number 4. Then so the output from the IC1 on pin number 6 will connect to the input will connect to IC number 2. So on, and then the ground, the part here is the ground, so we jump ground to here, and then this wire ground to connect to the ground supply, and this is output, so we'll connect to the oscilloscope.